Hello there. In this lesson, we're going to look at how to find images in concave and convex mirrors. As an example, I don't know how many of you have used one of these makeup mirrors before, but they are definitely a little bit concave. And if you move your face, and I tried to do this with my face, but I couldn't with the camera. The distance between the object, your face, in this case, this bottle, and the mirror changes the amount of magnification or even whether you can see an image at all. So definitely from this distance, you can see that the bottle has been magnified. It's still a virtual image. It still looks like it's behind the mirror, but it's definitely enlarged. So that's very different from a flat mirror like the one in the back here, where everything is the same size and distance as the object. So another one that I found that I think is really cool is this toy here. It's also concave. And if you put an object like this coin in the bottom and then put the top on, the top also has mirroring underneath here. And so what happens is the light rays bounce around inside here and they create a real image, which is like a hologram that floats right above this, this hole in the top. And yeah, so that's really neat and a great example of a real image that is produced by a concave mirror. Alrighty, so in order to determine where the image will appear, we're going to need some reflected light rays to guide us. So there's a few rules to follow, and you only need really two light rays to work out where an image will be. So first off, if you have a light ray from your object that is parallel to the principal axis, so if you remember, this here is our principal axis. So if you shoot a light ray that's parallel to that, it's going to bounce off and go through the focal point or focus, like that. Secondly, if you pass a light ray through the center of curvature, which is this guy here, it will just bounce straight off back on itself. Thirdly, if you aim the light ray at the vertex, which is here, it will follow the same laws of reflection as if it's bouncing off a plane mirror, because if you remember, this principal axis is 90 degrees at the vertex. So it just acts like a plane mirror, which means the angle of incidence equals the angle of reflection. And so once you have at least two of those light rays reflecting off, wherever they converge, that's where your image is going to be. So now I don't have an image yet in this diagram, but if I did, I'd keep following these arrows until they came together, and that would be where the image is. Okay, so this is our first example. Our object is just going to be an arrow. And for our first light ray, we're going to shoot that one parallel to the principal axis, and it's going to bounce through the focal point. And then for my second ray, I'm going to bounce it off of the vertex, which means angle of incidence is angle of reflection. And we see that the two rays cross here. So that means that our image is going to be at this point. So now let's use SALT to describe that image. Size, you can see that it is smaller than the object. Attitude, you can see that it is inverted. It's upside down compared to the object. Location, you can see that it is closer to the mirror than the object. And type, you can see it's in front of the mirror and not behind it, so that means it's a real image. All right. Okay, so case number 2, we've moved the object to the center of curvature. Let's put on our same rays. I like the one that goes parallel and through the focal point, and then a second one that goes to the vertice and back. And so you see that this time we are right at the same point. So size will be the same as the object. Attitude is inverted still. Location is the same distance. And type, it's still a real image. There we go. Alrighty, so we've moved the object now in between the center of curvature and the focal point. And let's see what happens to the rays now. shoot one parallel to principal axis, back through the focal point, shoot one at the vertices, angle of incidence, angle of reflection. Oh, look at this, we're way out here now. Okay, so we got ourselves a big arrow back here. So size, this time it's larger than the original. Attitude, still inverted. Location, now it's farther than the object. And type, it is still a real image. Okay, this time we've moved the object to the focal point, and let's see what happens. We're going to shoot the first beam through parallel and then back through the focal point, second one through the vertices and back out that way as well. And so as you can see, these two are not crossing, at least in front of the mirror. And if we project them backwards, they're not crossing back there either. So the conclusion here is that since the rays don't cross, you won't get an image when the object is at the focal point. If you're ever using one of those makeup mirrors, you'll get to a point where you don't see your face at all. It's not flipped upside down, it's not bigger, it's not smaller, you can't see anything. It's just a sort of a mess of light. And so that means no image, which means none of these can be satisfied because we don't have any image to describe. Okay, so this time we're going to move that object inside the focal point, see if we get an image this time. We'll start by shooting our old favorite light ray through parallel and back through the focal point. Secondly, we'll go through the vertices. Oh, they're not coming together. We'll try one more through the center of curvature. It just bounces away as well. So we got all of our beams in front of the mirror all diverging. So that means if we project them backwards, we should get to a point where they converge. So there we go. So instead of a real image this time, we're going to have a virtual one. So there we go. I almost said fake. Yeah, there we go. Nice big arrow behind the mirror. So this time the size is larger than the object. The attitude is upright, so not upside down. The location looks like it's a little farther from mirror than the object is. And the type this time is virtual. So if you're using your makeup mirror, this is the distance you want to be so that you can see all the stuff up close on your face and look after yourself, which is the purpose of the mirror. So that is the spot to put your face to get the nice magnified image that you want. Alrighty, so the last thing we're going to consider here are convex mirrors, and they're a lot more simple than the concave ones. There's really only one situation. It doesn't matter where you put your object in front of it, you always get the same outcome. But just to start here, we want to make sure that we have everything in place. Remember that once you put down your principal axis, that the center of curvature and the focal point are going to be behind the front of the mirror, right? This is the dark side or the back side of the mirror. And the focal point and the center of curvature are going to be back there. All the light beams that you shoot at the front are going to diverge from each other, and we're going to have to project back, which means every image that we find is going to be a virtual one. They're always going to be behind the mirror. Okay, so let's go through what happens to light rays when we shine them on a convex mirror. First off, the parallel ray that we are used to using to start off with, it's going to bounce off as if it's coming from the focal point. Secondly, if you shoot a ray right at the focal point, then it'll bounce off parallel to the principal axis. So that's those are sort of opposites of each other, and you can use those to help you find images. And finally, we can shoot one right at the center of curvature, and it'll bounce back as if it came from the center of curvature. All right, let's see if we can use that. So here we go. We've got our object again, and we want to find out where the image is going to show up. So first off, parallel ray, bounce it back as if it came from the focal point. Second off, we're going to do one that is straight at the focal point, and it bounces off parallel to the principal axis. So both of those obviously diverging. We're going to have to go backwards behind the mirror to see where they converge. So there's the one through the focal point. There's the one parallel to the principal axis. And so you can see that the image is going to be smaller and virtual. So the size is smaller than the object. The attitude is upright. The location is closer to the mirror, and the type is virtual. So all those, have you ever been like a convenience store and you look up and you see one of those sort of rounded mirrors that it's in the corner so that they can see people that are in the aisles, even when there's not a direct line of sight from the cash register? That's what they do. They allow them to see a lot more field of view, but everything's a little bit smaller. All right, so I hope that helped, and we'll see you soon.